Hello, good afternoon. Some people are still joining, but I think with a little bit of delay we will start our panel discussion, our session more specifically. We are meeting together today for road infrastructure maintenance and circularity. Probably if you look around the room, you know already, some of you already met before, so it's not only a networking event, besides presenting the project result, it's also a day where you may have the possibility to look towards the future, and not only towards the future in general, but towards the future of infrastructure and road maintenance. Today we will have 5 projects resulting from 2 different calls. 2 different calls, one in 2020 and one in 2022. Next slide. Okay. Okay, it's a lot of text, but some of you already know the text because this is the text that was summarizing the calls in 20 and 2022. The first call, which we have 3 projects, are OMICRON, InfraROB, and HERON, and then the second call in 2022 are resulting Circuit and LIAISON. The 3 projects coming from the call related to automated infrastructure call in 2020 are concluding this year. 2 of them, OMICRON in InfraROB this spring, and HERON towards mid of this year, May. Unfortunately, HERON will not be able to present, so I will be one-man show and I will present for the coordinator of HERON, but you will have in the room 2 other coordinators of OMICRON and InfraROB, 2 very successful projects which had the final event mid-January. So their project results are close to finalized, InfraROB and OMICRON. So if you don't know already these projects, please do I kindly ask you to take notes and ask the project coordinator. I hope that they will be able to reply to all your questions. And then very close to midterm are LIAISON and Circuit. Their midterm project reviews took place last month. So if there are questions that you would like to answer, ask them, please do so, so then you'll understand where their project results will be heading towards. So besides me, as a moderator, I will have Ciaran McNally from UCD, which will help me in the panel discussion at the end of this session. And I think I should start with the presentation of HERON, which, as I said, I just received the information that the coordinator is not going to participate, so I kindly offered my help. So bear with me, do not be tough on me. I know the project very well, but not nitty-gritty details. So HERON project, it's a 4-year project which will conclude at the end of May with a budget of around 12 million with 12 partners from 7 different countries. They are bringing together solutions which will be deployed in 3 demonstration activities in 3 countries like Greece, France, and Spain. HERON is designed as integrated all-in-one robotic platform that combines automation, monitoring, intervention, and post-intervention analysis to streamline infrastructure maintenance. As I said, the core philosophy of this project is automation and modular adaptability focused on a single robotic system that can perform all the tasks. By integrating AI-powered vision, robotic automation, real-time digital services, and with their project results, they will reduce their manual labor and operational costs while improving safety. So far, the results of HERON projects are significant. Their technology allows for a georeference inventory of large-scale road networks. They deployed and developed two models, vehicle-mounted cameras enabling real-time monitoring via patrol vehicles, and UAV-based inspection providing area road infrastructure assessments. HERON project has developed an unmanned ground vehicle equipped with a robotic arm designed to do all-in-one road maintenance solutions. Then later on, for key capabilities of HERON robotic platform, we have area closure. The same robot is deployed to secure and seal all the surrounding areas, ensuring safe working environment for the road maintenance to begin. Pothole sealing, it's designed to automatically fill potholes, improve road conditions. Road marking repairing, ensuring traffic lanes and other important markings remain visible, and crack filling, pavers, which are designed to repair road surfaces by addressing cracks before they worsen. Then we have the incident management service, which acts as a real-time view of the infrastructure with key elements like visualization of assets, defects, and robotic operations in real time, mission planning for UAVs and UGVs and maintenance teams, and remote monitoring, which allows the decision makers to track and supervise the maintenance operation for from a centralized dashboard. And then the last element which HERON project worked on was the augmented reality, which provides real-time overlays of infrastructure defects and assets, which is presented in the short video. And then for HERON project, we have two types of benefits which were identified so far. The short-term benefits are three specific points which can be defined as faster detection and resolution of infrastructure defects, manual labor is reduced and improved road safety for workers, a more efficient road maintenance operation, and when it comes to long-term benefits, cost savings in infrastructure lifecycle management and data-driven insights to enhance urban planning. HERON project can be deployed and scale up in smart cities application and other domains. For the moment, the project is in testing period and will conclude end of May. And the final project results will be presented in a final presentation later this year. This is me, the PO, presenting in the shoes of coordinator. Sorry for not having so nice presentation. However, we will go to our next project coordinator to present InfraROB project, Pedro Arias Sanchez, presenting InfraROB project.
Thank you, Mrs. Chairman. Good afternoon to everyone. I will to make a presentation of the InfraROB project, and the presentation will focus in the results and the project impact achieved for that, right? And the presentation is divided in these main 4 points. I'm talking about the first. The project is a research and innovation action. And the main figures of the project was the duration was 42 months, and with person month dedicated to the project was 669 person month, and the budget was about 5 million euros. Talking about the consortium was made for 18 partners from 8 different countries. Like you can see, it was a good balance consortium with a representation of a small and medium enterprise, academic institutions, large enterprise, non-profit associations, and public owner corporation. And to achieve our objectives, focusing the positive impact in terms of safety and efficiency, we have divided our project in 5 main technological areas. Our objectives was to achieve to TRL 7, and that means make a demonstrations in the operational environment. For that, this is the image of the 5 technological areas, and for that we have tested our results, our systems that we have developed in the ASFINAG road infrastructure facilities. Talking about the technological areas, and the first technological area was dedicated for big robots, and specifically was a robot for operations in road and for upgrade and construction of roads, and specifically with the focus in the asphalt layers of roads. And the second technological area was dedicated to the small robots, and specifically we have developed in this area 2 robots, and for repair cracks and potholes, and another one for develop a robot for painting roads, for lane painting roads. And the technological area 3 was dedicated for design and develop a multifunctional all-in-one precast component, a barrier, a road barrier. The technological area 4 was dedicated mainly for safety issues, and for that we have developed 2 different components: a drone equipped with some sensors, cameras, etc., and for the other side robot cones, right, for segmentation and signaling the areas in roads. And the last but not the least technological area was dedicated for upgrade management system in roads, and we have put the focus in the upgrade of the pavement management system and to the upgrade the traffic management system, right? The main results of the project is included in the next 2 slides, and we have I made a summary of the main results of the project. And in this first slide, we have included 4 results, specific results, and the first one was a big robot for the autonomous working in road construction and maintenance. Some characteristics of that is fully autonomous paver machine. No personnel are required for the work of this solution, and the control over the 100 meters is about 1 centimeter, and the precision is over to more than 2 millimeters. And the patent actions in this case is in progress, and the company is working on that. And the second solution, or the second develop of the project, was a solution for automatic cable laydown during the paving process, and specifically was dedicated for inclusive or for lay down of fiber optic sensors, right? And using these fiber optic sensors for damage monitoring. And the main results of this activity was develop the automatic laydown system, And was important as well the definition of the suitable fiber optic sensor, fiber optic cable for this application. And the characteristic as well of the solution is a long distance application, length up to 2.3 kilometers with a spatial resolution of 10 centimeters. Another solution, as I have commented before, was a multifunctional precast concrete component or element. The characteristics of that is all-in-one is included a drainage solution for roads, and as well the possibility to include inside of the barrier some facilities like power lines, fiber optic sensors for communications, etc. And some characteristics of this solution is, like you can see in the slide, this installation time is reduced regarding to the normal barriers. It's about 47% less reduction time. And the reduction in on-site workers is more than 20%. And was included as well, was made this barrier with more than 57% recycled materials, and the design of the barrier was considering the safety measures. And the production cost of this component is about 100 euros per meter. The patent of this solution is in progress as well, and the company is working on that. And another robot is a robot for autonomously working lane marking robot. And in this case, the accuracy is sub-centimeter, and the painting speed 1 meter per second. And the painting capacity is about 1,500 meters of solid painted line with working in fully autonomous mode. This solution is partially patented. And the other results of the project, like you can see in this slide, the first one is a robot or machine for autonomous repair potholes and cracks. In this case, the characteristics of this solution is possible to work this machine with potholes with about 20 centimeters of diameter and maximum depth 4 centimeters. This solution was include a camera and RPI for device for location and volume characterization of potholes. And the other important characteristic is the road section can be reopened immediately after the reparation. The next results of the next develops of the project was cones and drums for safety. I have commented before, was divided in two components for the cementation of the roads where workers are working on that. For that, the main characteristics of drone is equipped with a camera and LiDAR sensors, and is possible to profile detection and tracking vehicles, up to new vehicles per frame, and with 90 frames per second. The solution included the possibility to assess the trajectory with the characterization of speed acceleration of vehicles, and as well with surrogate safety measures of that. And finally, the cones, the robotized cones, the characteristic of that is the navigation of that is a centimeter level and with F2X communications for near real-time alerting. And the next solutions was all of them was developed for upgrade the management system of roads. And the first of that is a pavement management system, and was developed for easy integration with the digital twins. The characteristics of that is this solution, this pavement management system, is the possible to predictive identification of the surface defects. As well, we have estimated that 20% of cost savings, with a pavement lifespan between, extending the pavement lifespan between 5 to 7 years. The the traffic management system upgrade, considering the introduction of robotics. We have developed this solution based in CITS communications for road work zones, for safety of road work zones. We have estimated that we can reduce the probability of the accidents involving road workers between 30–70%. And last but not least, the digital twin was developed as well for the project. And was developed for the easy integration with a pavement management system. And we can obtain from this solution real-time insights, predictive maintenance with identification of potential maintenance needs. And it's possible as well to include as integration different sensors, integrate these sensors for real-time monitoring, and specifically for the fiber optic sensors, right, for monitoring. And finally, data-driven decision-making for road infrastructure management is possible based in the digital twin. When the project started, we fixed some KPIs for the impact of considering the impact of our solutions. And we have started with some figures, like you can see. For example, in the reduction fatal accidents, our objective was to achieve to the 50%, and we have performance to reach this number, 50%. And the initial intention objective for reduction of traffic disruption was by 20%, and finally we have managed to reach 35%. And reduction of routine maintenance cost, the initial intention was to achieve to 20%, and finally we reached 35%. The improvement of network capacity when the project began was 20%, and finally we obtained a KPI about 25%. And talking about the impact of the project and considering the mid-term and long-term, we have analyzed the impact. We have made an estimation of the impact and considering five different components, right? The technological, the environmental, economic, societal, and input to the policymakers. And the figures that we have estimated is, like you can see, is considering the technological component. To the mid-term is to increase the 5% extension of the road pavement lifetime. And to the long term, our estimations is about 15%. And the environmental component, we consider that the solutions of InfraROB can reduce the emissions by 5%. To the mid-term and long-term is we can reduce, or our estimation is to reduce to 20%. And considering the economic impact, in the mid-term, our estimations is to increase the efficiency of the allocation results between 10–15%, reduction of number of workers and cost from 4 to 2 people, and to the long term reduce the pavement time and workers' labor cost to zero, right? And considering the societal impact, to the midterm, safer roads and improved traffic flow for less stressful travel experience, and with less than 10% of the exposure to the traffic of road operators. To the long-term increase of road workers and users, detecting safety incidents beyond of the human perception. Finally, and the input to the policy making, and with the results of the project, to the impact to the midterm is to facilitate the standardization of the CITS message. And to the long term, once standardized, the OMs could develop communications protocols based on OBUS and a device for road workers. And go to the last slide. Another results, considering communication, dissemination, and exploitation. This is you can see the figures that we achieved in the project, and the communication, the figures about social networks, and visits to the project website, followers in social media and publications, and in dissemination, we have participated in 21 conferences. We have published 24 scientific papers, and we have published 9 e-catalogs of the solutions. And that's all, and thank you for your attention.
The last project from the cluster of 3 projects funded under the 2020 call is OMICRON, presented by José Solís Hernández. It's also dealing with automation and optimized maintenance. Thank you.
Good afternoon, everyone. Well, first of all, thank you to the organizing team for inviting us to present our project today. As Claudia said, my name is José Solís, and I work for the R&D department of CEMOSA, and I'm also the project coordinator of OMICRON, which I have the pleasure today to present to you. I will structure my presentation in 3 main areas. First of all, I will give a brief overview of the project. Then I will go through the thematic areas of the project itself, and then we will present the demonstration, the impact, and some conclusions. And starting from the concept of the project in a nutshell, we have worked on developing innovative infrastructure technologies for Europe during the last 4 years. OMICRON is a research and innovation action in which 17 companies, organizations have worked together, from research institutions and technology developers working alongside ICT integrators and dissemination communication experts in order to develop new solutions for road contractors, road operators, or road owners. The concept of the project is the development of an intelligent road asset management platform, and the project is based on 4 main pillars, starting with digital inspection, the development of a road digital twin, the development of a decision support tool, and the development of smart construction and intervention solutions. We cover the life cycle of the infrastructure, aiming at increasing network capacity, reducing costs, reducing traffic disruptions, and reducing the number of fatalities, following what was presented by Pedro in the previous presentation. In terms of project results, I will follow these 4 thematic areas and present briefly, in the time we have today, the different developments of the project. Starting with digital inspection technologies, the project has developed a UAS management tool integrating multi-UAV and long-range capabilities. We have also developed the Point Peaks terrestrial inspection vehicle from University of Cambridge, integrated an innovative camera sensor combination. And we have worked on V2X communications towards CITS systems in order to provide information to road operators and also to users regarding maintenance state, weather, traffic, etc. With respect to the UAS inspection tool, the objective was to improve efficiency in inspections using multi-UAS and long-range inspections. And we have been able to reduce inspection times by 2.4 minutes per kilometer, reduce inspection costs by 12.5 euros per kilometer, and all of this has also affected a reduction in traffic disruptions, time, and human error. Moving on to the next block of technologies, we talk about the OMICRON intelligent platform composed by the digital twin and the decision support system. And I always like to start by defining what we understand by digital twin, as it is nowadays a buzzword which we hear in many areas. So the concept was the development of a virtual replica of the infrastructure based on a BIM-GIS-oriented environment and providing capabilities towards asset visualization, asset state prediction, and simulation capabilities towards decision-making. The digital twin enables connection to static and dynamic data, the integration of all the sources of data from the project, and the integration of relevant sources of data and analytics from the decision support system. With respect to this decision support system, the objective was the analysis and prediction of asset condition and also traffic state in order to improve the way in which we schedule maintenance. So within OMICRON, we focused on three main applications. The first one was pavement condition prediction based on historical data. The second area that you may see in the slide is structural health monitoring on bridges using IoT data. And the third area is focused on planning and optimization of maintenance activities using the information from the other two. These three applications were integrated in the DSS, in Zenbox digital twin platform developed by Cemosa, and you may see the results in this short video. Going a bit more into detail into the second application, we worked on structural health monitoring of bridges, and we developed a methodology starting with IoT data and defining a continuous operational model identification. The development of a routine to remove environmental and operational variables. We developed a finite element model and surrogate models for the bridge that we analyzed. We developed a module for damage identification and a control chart. And last but not least, we performed inverse optimization for using AI to identify damage. This leads to the third application, again, focusing on planning and optimization, where we followed 5 main variables: priority, degradation, average queue length, average delay during maintenance, and average delay due to traffic disruptions. And the objective was to develop a optimization algorithm in order to optimize the assignment on work zones to time intervals, as well as the definition of work zones according to certain configurations, depending on the needs of the particular work zone. This leads us to the final area, to the last area of development of the project, which is focused on smart intervention solutions. The project developed a robotic modular platform based on a business case in which we didn't want to only address one maintenance intervention action, but various of them. So the robotic modular platform has been developed to cover safety barriers replacement, installation and removal of cones, safe signaling during construction, sealing of surface pavement cracks, road asset cleaning, or laser removal of lane markings. The result has been a drastic improvement in safety, removing workers from hazardous areas, while competitive performance, time and costs, especially in certain applications, where one of the most promising ones is the one related to crack sealing in maintenance operations, where a full robotized operation has been developed, developing a tool which integrates 4 operations at the same time, which is cleaning, heating, applying bitumen, and applying aggregates. And let's say performing an automatic crack identification and path using deep learning technologies. Last but not least, the project also addressed the rehabilitation of surface pavement layers, installing sensors such as in the whole process, such as asphalt track traceability, paver and roller location, thermal control and weather conditions, as well as macro texture monitoring. This allowed the analysis of the whole process and all of the steps within this process, promoting also the use of greener pavements, including AUTLs with recycled asphalt and crumb rubber. As I said in the last part of the presentation, I would like to talk about how we demonstrated the project and the impact of OMICRON. So, how did we put this into practice? We had a clear methodology in order to arrive to TRL7, starting with preliminary testing and TRLs 4 and 5. Then we move on to technical demonstration of specific technologies at TRLs 5 to 7. And last but not least, most importantly, we developed a final demonstration of the platform at TRL 7 as OMICRON's final showcase in the A1 from Florence to Bologna, hosted by Autostrade per l'Italia. This enabled us to evaluate how the technologies did within the framework of the project based on 14 KPIs that, as Pedro presented, elaborate on 4 main KPIs, which are the reduction of fatal accidents of road users and deployed personnel by 60%, the reduction of traffic disruptions due to maintenance by 32%, the decrease in routine maintenance costs by 39%, and the increase in network capacity by 20%. Not only on the technical side, but also on the standardization side, we developed 2 CINEA workshop agreements, one on XR and robotics applied to roads and also on decision support systems. We have 2 patents, 13 peer-reviewed publications, 12 journalistic articles, 9 publications in conferences, fact sheets, videos, etc. We also had a very important and relevant external advisory board with 6 workshops which were held online with more than 80 attendees. And as Claudia already mentioned, a final event alongside InfraROB and HERON at the Institution of Civil Engineers in Madrid last January. And last but not least, in order to conclude, following the findings of the project and also the feedback from the External Advisory Board and this final event, we have, let's say, some conclusions towards related to policy making. The first one is that Europe clearly needs to drastically reduce and simplify regulation to support innovation and boost our competitiveness. This is something that was perhaps said today in the opening ceremony. In order to compete against countries like China or the US. From our side, this was particularly clear from the perspective of drones or AI. The second point is that the transport sector, and particularly the road sector, being Cemosa a civil engineering company, needs to rethink public procurement and improve the collaboration between the public and private sector. And last but not least, our project results, such as Zenbox Digital Twin, addressing digital twins, will need to continue evolving towards other aspects, such as addressing resilience and the response, how we tackle extreme events. Thank you very much for your attention, and I will be more than glad to answer any questions later on.
Okay, thank you, Jose. So our final two speakers are presenting projects that come from a separate call. I'd like to invite our first presenter of those two, David Garcia Sanchez, to speak about the LIAISON project.
Okay, so thank you very much to all of you, to the audience that you are here today. I see a lot of friend faces, so thank you very much for your attendance. Also the people here is connected remotely. So yeah, the main challenge of this project is, as you can see here, lowering transport environmental impact along the whole life cycle of the future transport infrastructure. That's why we call this LIAISON. And it has to say in French language, because the idea is that, to make the liaison between the different concepts, trying to decarbonize the transport infrastructure. Sorry, that is. Okay, yeah, so the main work here is decarbonization. And to do that, the first thing is to build a very talented team. That's the one that you see here, covering all the value chain for the transport infrastructure, for rail and also for roads. So we have in the consortium construction and consultancy companies, Ciuca, ideas from Ireland, RINA from Italy, industrial partners such as Citroën and Vita, RTOs such as Technalia, the one I'm representing here today, Codepon, SAG from Slovenia, UC Spain, and University of Minho, Portugal. We have also owners, operators and validators such as Strade per l'Italia, CEDEX, Promini Institute from Ljubljana, and also the ministry in Spain, and of course a company for exploitation and dissemination such as ICONS. The total budget of the project is 5 million euros. Yeah, and the overall objective of the project is, as you can see here, 4 main points. So for us, we clearly see from the very beginning that we need to not only develop technical solutions to reach the market properly as an innovation action, because this is an innovation action. And to do that, we clearly see that our solutions should be focused on minimizing the consumption of the resources. We clearly see that, okay, we can reduce this kind of consumption in more than 20%. The reuse of the available materials is another really important point and really important objective of the proposal. The third one is how to evolve towards a prosumer infrastructure. That means that, okay, we all of us, we know that our infrastructures and the components of our infrastructures are, of course, built to support and to make real the transport service. But it's true that we can ask more things to these components and these infrastructures. So here in this project, we are asking them to provide energy in some particular elements, as you see later on. And the fourth one, as I said at the beginning, we clearly see that we need to close the loop between what the researchers are doing, what the market is asking for, and how the administration is dealing with the tenders and procurement processes. So it's quite early for us to talk about results, of course, compared to OMICRON and to InfraROB. It's a little tricky to make this third presentation after seeing such impressive solutions, but okay, we can share with you some the work we're doing right now as example, okay? So the first one is this. You see here a flowchart, a complete flowchart that is really important for us. It's really important for the project because all the solutions we are developing have to fulfill this framework, because all the solutions have to be coherent with the objective of circularity, sustainability, and so on. Yeah. So the first thing that we are developing in the project is this general framework, and also in a complementary way, all the tender process that we are launching with the different administrations during the demonstration of the solutions. Okay. From the technical perspective, we classify our solutions in industrialized solutions, circular solutions, and operation and maintenance solutions. So in the first one, the industrialized solutions, the most relevant solutions are those that you see here in this picture, okay? So on the left, we see the modular rigid pavement for roads that is being developed by Acciona mainly. And here, the objective and the prototype that has been developed is a concrete slab, minimizing the use of cement, okay? Here, we are working with geopolymers, we are working with GGBS, we are working with these neutral materials, trying to avoid the use of this cement, trying to help in the transition, okay? Zero transition. So, of course, on the one hand is the material, but on the other hand is the design. As you see here, we have developed a complete design, a complete new design based on different standards in the USA. But the main and important point here is the possibility to assembly and disassembly as many times that we need theoretically, trying to close the loop and to make the reuse concept as real as possible, okay? Another important point is that all these modular rigid pavement for roads are equipped with WIM sensing. The idea, of course, is to change the paradigm to products as a service elements. As I said before, we need to think different, and the idea is not only to build things, but also to transform this, also providing information, make the way to build these digital twins that we need for that digital environment management, okay? The second solution that you see here is the optimized smart bin manufacturing. Here, the idea is to reduce the material, the concrete that we are using. So this is, as you see, an optimized design, minimizing as maximum the material we need to support, let's say, all the loads that the structure has to do. So, on the bottom of the slide, you see two pictures, and you see the clue here. The clue is that, okay, we have designed some special molds has a very specific, very optimized design, and is the clue to make the beam real. Of course, the positioning, the location of the different elements, also the parts, has done using different digital tools, and is in parallel allowed to create and to be managed with this digital system, because it's exactly the same. We are equipped this beam with fiber optic sensing. If we talk about circular solutions, we are putting the focus in the LIAISON project in the bioasphalt pavement and also in the low noise and vibration circular railway track ballast for railways. Okay, regarding the bioasphalt, the idea, of course, is to reduce maximum the use of the bitumen, but by the use of these new bio-benders that you see here. I don't know if you are familiar with them, but there is a list of them. And during the project, we have been testing, trying to analyze the most convenient one according to the framework that we show at the very beginning. So that's why here you see on the bottom technical aspects, circularity aspects, cost, environmental, and social as well. In the right part of the slide, you see the low noise vibration circular railway track ballast. This is a solution that we are working with the Slovenian railways. And the idea, of course, is to provide a solution to a problem that is common to most of the countries that there is Europe. Okay, so the idea is to improve the performance, the mechanical performance of the traditional ballast that they are using, and also improving in terms of dynamic behavior and also in terms of noise. So the idea here is just to mix the ballast with the rubber coming from waste tires, and and also we are building some small walls that you see here, some concrete small walls, just to contain the ballast, and also just to minimize the potential leakage of the dust coming from the tires that could come to the environmental. So finally, these walls are equipped with noise barriers. These are the solutions from the circular perspective. Finally, the solutions for operation and maintenance are mainly focused in three. The first one is the tunnel energy optimization for the tunnel. Here we are talking about minimize the energy consumption in terms of lighting and tunnel fans of tunnels. And to do that, we are working in parallel. On the one hand, defining different scenarios, trying to be more agile in the management of the lighting in the tunnel. And on the other hand, we are working in different frequency variators in the tunnel fans, just to trigger them when necessary, but also balancing the consumption and the quality of the air that we need to assure. The second one, that is just in the middle, is a photovoltaic guardrail. And here, this is a solution that we are developing with Vita Italia and our colleagues from Technalia. And as you see here, the idea is just to keep the guard barrel with a new element that is integrated in the existing one. And of course, the idea is just to provide a solution to solve the problem of the fragmentation of the natural environment that is all around the roads. So traditionally, we see that we have different solar panels all around the road areas with different electricity gadgets and different elements. So the idea here is just to integrate all of them just in the guardrail. Nowadays, this is a prototype is working, and you see here, okay, some details of the energy that is providing, and the performance from the electrical part. The third one is the one dedicated to the pavement damage detection tool. And compared to other solutions, the main important thing here is that, okay, we are recording video with a camera that is located in the back of the car. And then we apply different techniques just to take information of the condition of the pavement. This is something that is being under development with the collaboration of the ministry in Spain. And of course, as the rest of the solutions that I've been presenting will be tested during the demo part of the project that will be in the last months. Yeah. So regarding the cross-project cooperation, as Jose mentioned before, and as Claudia suggested during our last meetings, and this is a message to Irina, we need to create a final event in 2026, hopefully such successful as the one from the OMICRON, InfraROB, and HERON. And okay, so that's why, and also paying attention to the A of the khaki word that our colleague mentioned in the previous presentation, we need to be more associated, okay? Regarding the mid-long-term expected impacts of the project, as you can imagine that it is quite early to give you figures and numbers about all of this. But I would like to emphasize some points that at this moment we clearly see, and I think it's important for the last period of the project. Regarding the LIAISON Dynamic Multi-Infrastructure Governance Framework, the DMIGF, it's useful for us to frame all the technical solutions, but as I mentioned before, it's allowing us the possibility to launch real tenders to give our solutions to the market. So this is something that we're really proud at this moment of the project, because we think we are finding the way to give the solution to the real world and to the construction companies, because we are writing these tenders and giving to the real process. And I think this is really interesting, accordingly also as such innovation actions as it is. Regarding the industrialized solutions, I would like to give you just two ideas. The first one, that is regarding the modular rigid pavement for roads. For us, it's really important to provide a solution that is assembly, and of course, disassembly. Okay, if we want to make things reusable, we need to work on this kind of designs. This is really challenging, but I think it's really important. Okay. Regarding the smart beam manufacturing, I can tell you that nowadays we are starting with the different discussions, because we see that, okay, the molds, the formworks that you see at the very beginning, that is the clue of the solution. We are analyzing if they have some kind of a structural contribution or not contribution from the structural perspective. So thanks to the collaboration of our colleagues that are working in the Euro codes from the structural side, we are discussing nowadays this point. Regarding the circular solutions, and in particular regarding the bioasphalt pavements, I would like to highlight that we are identifying some barriers regarding the supply chain. Biobundles are sometimes difficult to access, and this is something that, once again, pay attention to the main lectures that we heard before. We need to think once again in the A of the associative, because if we are HERON, we want to be ready to the challenge, we need to work together in a collaborative way. Okay, so we clearly start seeing that biobundles could be a problem. Okay, regarding the low noise and vibration circular roadway track ballast, we are for sure thinking that these solutions that we are providing could be extendable to the rest of the East European railway managers as a common problems. Finally, for the operational maintenance solutions, okay, in particular regarding the tunnel energy optimization and the digital twin, yeah, this is a solution that can be extensible also to not only to road, but also for rail, of course, metro, mining, and in the industrial sector. All the sectors that are working with tunnels or underground structures. The photovoltaic guardrail, we see, and we are working also in other applications for other road rail components. Regarding the pavement damage detection tool, as I told you before, the main important thing is that, okay, we are recording video, we are driving at 80 kilometers per hour. That is a very, very nice speed if we consider the rest of the solutions. We are very happy with this evolution of the solution. So this is all for my side. I'm hoping in 2 years I can give you more specific figures. So thank you very much.
Great, thank you, David. Our final speaker is Irina Stepanovic, who's going to speak to us about the Circuit project. So.
Clearly, I'm not Thierry Roger, General Secretary from HERON. Unfortunately, he was not able to present today, so he's a coordinator of Circuit project. And myself and Carlos, now help me with the long name, Martin Portuguese from Acciona. We are together scientific and technical coordinators of Circuit project. I'm coming from Croatia, and I'm director of InfraPlan Consulting, SME. So as you can imagine, we both LIAISON and Circuit responded to the same call, so there will be lots of similarities, but luckily also we have some specifics and different approaches. So Circuit is focusing on developing a holistic approach to foster circular and resilient transport infrastructure, and particularly also to support the deployment of green and innovation public procurement and innovative engineering practices. So the project is now, let's say, 1.5 years in place, going towards the end of the 2nd year. The budget funding is 4.8 million euros, or the total value is 5.7, and duration is 48 months. We have 20 partners coming from 9 countries. You have seen the numbers. It's a very nice consortium in the sense that we are covering big industry partners, owners, SMEs, and research institutes. I would say this picture shows the main concept of Circuit. So it relies on 4 pillars. And overall, it's covered with a framework, holistic framework, which should enable circular, smart, resilient, and sustainable transport. And now our 4 pillars are digitalization, recycle, reuse, and energy. In each of them, we have a number of innovations, and they will be implemented and demonstrated at the pilot projects. Also, important difference is that we are innovation project comparing to the first 3 projects. So we are going to demonstrate and implement and validate the solutions which are aiming to be at the TRL level 7, 8. At the bottom, you can see we try also to link the construction industry with the society as a whole, because that's actually in the end most important, that whatever we want to improve, that it's relevant for us as a whole society. And the link we see as a green public procurement. So I will go through our pillars and of course what has been developed so far. Please follow the project on all social medias, and we will try to be very informative. So far so the general digitalization main concept is that we are integrating all the solutions into digital platform, which will be BIM GIS based, of course, but what should be innovative, that we want to link existing database to the new tools, meaning, for instance, that a lot of products have been certified or declared EPD, Environmental Products Declarations, but unfortunately they haven't been implemented or in use overall in our projects. So for this link, we are going to use Innovative Graph database to link information which exists also to our existing and future projects. Then a next integration is development of digital product passports, which should be similar to CE sign or certification of all our construction products, but now they should have chip or different ways of a barcode, which should trace each product from the birth to the end of life, or hopefully a new life, with integrated information about all the resources, all the energy, all environmental impacts, and finally, where they could be reused in the future. So we are testing right now with Spanish Institute for Concrete and Cement chips, RFID chips, which we are built into the concrete. They will be also implemented into the bridge beam and then reused finally in the bridge. The framework which we are developing, or which we have developed, the KPI framework, is covering these 4 aspects. I won't go into details. We published a deliverable with all quantified, of course, based on the existing frameworks and standards, and then with some new additional ones, starting, let's say, from a really material, product, element, and then system, and then network and the society as a whole level. So how to link design or existing project and how to fulfill the requirements to the final use. One tool which we developed and we are now applying for different design solutions is Circularity Analytics tool. And it is now developed for the bridges. So let's assume we have all our existing bridges. The owner of the highway wants to know how many of the existing bridges can be actually reused. So how many bridges can be dismantled? The point is that we don't want to demolish and we don't want to crush it and downcycle. We want to keep the elements as a reuse. So we try to make it automated way, so we have a BIM model, or if we don't have, we have to scan, develop a BIM model, and then automatically get the KPIs, how many of those elements can be reused. We already faced, of course, lots of lack of information, because the most important, you can imagine, is how to disassemble. It's important to have defined connections, accessibility, transportability, etc. But we are really looking forward, and we are aiming to make this as a product. We have 5 pilot projects, and luckily we have owners of those locations, or let's say road infrastructure, as partners, which ensure the full commitment and implementation of the solutions. We have 2 free highway owners, Italian ANAS, MITMA from Spain, and Croatian Motorways. We have a Slovenian municipality and Dutch water board owner of the flood protection system. So in Slovenia, we are going to build a bridge from reused structural elements, and then which is focusing on the beams, but also on the reuse of the abutments, as well developing a 3D concrete printed side elements, fences with the implementation of recycled materials. In Italy, the focus is on the solutions for energy, so low energy solutions for ventilation and lighting. In Croatia, we are focusing on digitalization and exactly applying the tool, Circularity Analytics tool and supply matchmaking tool, which I haven't mentioned, but we also want to link future projects with the existing resources. In Spain, we are focusing on the implementation of asphalt with recycled and also bio-based materials. And in the Netherlands, the focus is on the geotechnical structures, so the implementation of soil strengthening or the implementation of recycled materials or waste in the soil strengthening. So far, I would say we have achieved one most important result, except developing already technological solutions and proving the materials in the laboratory. But I would stress Spanish colleagues did an excellent job on a large survey on the existing barriers and opportunities for implementing green and innovation public procurement. It was based on the literature review, online survey, and expert interviews. And as you can see, it's a public report, but barriers were identified in all these three sources in the same categories. And we are facing serious barriers, which were already mentioned, related to regulation, related to the market and supply chain process, and then also existing strategies are not supporting circular strategies. So out of that, of course, we want to propose solutions and how to the way forward. What we promised in the project, that we will cover the whole supply value chain, and we do have in the Circuit project all the partners covering the whole supply value chain. So we would like to support the production, of course, reduce the usage of virgin materials and implement, increase the reuse and usage of recycled and waste materials. We want to support the design process for the new structures and enable easier access to the existing databases. And of course, we want to support green public procurement process, specifically to provide to the owners KPIs or exact numbers which should be used in the green public procurements. One of the major barriers and the answers was that actually the owners don't know what to put in the tender. Unfortunately, although we are doing all amazing research and there is a lot of that available, usually the solution is chosen based on the price and price only. And that's it for the moment, so I am not going to talk much longer about the expected impacts. We are going to hopefully prove all that, and we are quite ambitious. And thank you very much for your attention.
Okay, thank you all. So at this point, we have time for, say, a number of questions from our panel. We have a microphone at the back of the room, so if you would like to ask any questions, then please put up your hand and we'll have that sent over to you. When asking a question, can I ask everyone to give their name and affiliation? Great, thank you.
Hello, good afternoon. My name is Ricardo Tiago from the Institute of Mobility and Transport in Portugal. Congratulations for all the presentations, and I have a couple of questions for Pedro and David. You mentioned, Pedro, the use of robotized machines for lane markings, but you mentioned the limit of 1,500 meters, I guess. Is that limit regardless of the ink that you use, or is it regarded as the tank that the machine uses in terms of more capacity of ink? And to David, regarding the photovoltaic barrier, how do you combine that approach with the European norm for safety barriers in terms of the quality of the barriers and the absorption of energy in terms of an impact? Thank you.
Can you hear me? Yes. Thank you for the question. The limitation in our case, in our solution, is based in the volume of the tank of the paint, right? The developers has a balance between the capacity of tank and with the size, etc., of the device. And in this first prototype, was a first prototype of the solution, and the limitation goes for the volume of the tank, right? I don't know. It's clear. Yeah.
Yeah. Okay. Yeah, the question is really convenient, not only in terms of safety, but also in terms of fire. Because during the project, we discovered that fire is another important condition that we need to bear in mind, in particular with some administrations and some standards. In terms of the safety, we have a very fun dummy test already developed with this prototype, and we are happy with the results. We are ready to, let's say, from this part to put in place, to put in the roadways. It's solved. It's a problem that is solved. But the problem that we are investigating and working right now is the one related to fire, because in some countries, for example in Italy, that is in particular where we are going to validate the solution, they have a very restrict standards in terms of fire, and it's a particularity of the Italian regulation. So nowadays we have a prototype that it's a good solution in terms of safety, and could be put in place in Spain or France or Portugal. But due to the fire condition, we can't put or implement in the Italian part. But the safety part is completely developed and solved. As maybe you've been involved in this kind of calculation, the final models of these barriers is the element is quite simple, but from the dynamic point of view and the mechanical point of view, it's quite complex because of the deformation of the elements and so on. It's really complex. But this is solved. The problem right now is the fire.
Okay, thank you. Have we other questions? We've one on this side.
Thank you very much, and I agree with the previous person thanking you for the comments and the presentations. Magnus Granström, Chalmers and SAFE. I have a question to the InfraROB project regarding the drones. Very, very interesting to see how that is used. Two questions really. Did you need to have specific allowance to use the drones close to the roads? I assume so. But was that difficult to get? That's my question number one.
Okay. All the regulations about drones are very complex, right? But in our case, we use a drone with achieve or in accordance with the regulations for working in roads. The roads is a specific environment in the regulation, following the regulations about drones, because it's considered like more or less close to the city, because the cars is moving, then the cars can be affected. Then the first thing that we have selected based in the payload the characteristics of drone, right? And that can be used in this environment. And for other side, we need to achieve a couple of regulations. The minimum distance to the road is 50 meters. And the altitude of the drone is as well 50 meters over the ground, right? Then was the main regulations, and considering the kind of drone, the type of drone that we have selected based in the payload, and for other side, the distance to the road, right? This is the main characteristics or the main limitations for drone. Another consequence of that is the payload that we have included, because we have included a camera, LiDAR, sensor, for other side a specific target for make a processing of the information in real time. Then was a complicated look for a solution that achieves all these requirements, right?
Yeah, I can imagine. And impressive, I think. And the second question then, would you, or are you able to detect more things, not only save time, but also other types of defects and so on, as compared to traditional methods?
But you are talking detection of Our intention was to use the drone for safety issues, right? Then for us was important to make the detection of cars with different kind of cars, vans, normal cars, trucks, as well the workers, right, people. Then we put the focus in these different elements, in these different components of the image, right? Then thinking about the cars, all kind of cars moving on the road, and the workers working at the same time. And as well, was important for us to make the automatic detection of the robots, of the machines that can work together with the workers, cars, all at the same time, all together. Then was our intention of the project. We didn't put the effort in another identification of another components or pathologies of the road, etc. I don't know if I understand your comment.
Good, thank you.
Okay.
Okay, thank you.
Yeah, I think with respect to recognition, well, Claudia was saying, with respect to recognition in our project, let's say we had a different approach. In our case, the objective was recognition, so it was infrastructure inspection, not so much safety. And in this respect, we were, again, coming back to your first question, we were slightly limited by distance, focal position, and regulations, indeed, in order to, let's say, have a full picture of defects within bridge or an infrastructure asset, although the results were positive, were good.
I might follow on from that, Jose, with you, in that the questions to date have all dealt with regulations, and this was a point that you specifically made in your conclusions. On a more general basis, could you comment on, I suppose, the barriers coming from regulations in maybe addressing some of these topics?
Yes. Well, first of all, I'm not an expert on drones, but we have been following this, so I can work from my experience in the project. First of all, although regulations are more or less handled at an European level, I would say the first barrier you have is that if we are operating with operators from Spain, as it was the case of OMICRON, and you go to Italy, you need to go through an European process, but then through the Italian process. So this is one barrier, which I guess could be improved, because this means time. So we had to plan the final demonstration 1 year in advance, let's say. The second group of constraints, I would say, are mainly on what the gentleman just highlighted, on distance to roads, position, and permits that you have. In our case, we had to be between 50 and 150 meters from the infrastructure. This means that although you can go with optics, you can go and have very good resolution, you cannot do magic, let's say. So in this respect, there are limitations. If we were allowed to go closer and with another type of safety measures, we would be able to be faster and much more in detail. Also, it is some of the restrictions are related to moving traffic. So in this respect, in certain areas, and I believe this is a special case for Italy, with traffic, it was very, very difficult to deal with a drone flying above, even if you were 50 meters above. So, well, this is another restriction. You do not have, you need to stop traffic somehow, and you cannot use the full potential of the drone. So this is where I would say regulation can somehow exploit or help to exploit all the benefits that this type of technology has.
Okay, thank you. Irina, did you want to come in there?
Let me add an example that we have, or our experience that we have in relation with the drones for the InfraROB project. As Jose has commented, we need to ask to make an operator to fly with drones. Then we start the process with the Spanish administration to make a registration of a new operator, right? Then we need about 15 months for get the positive answer about the new operator for make this operation in Austria, right? Then we need all this time. Then we follow the strategy to ask to the new operator to the two countries at the same time, Portugal and Spain, because our confidence to achieve on time with the new operator was very worried, right? And finally, when we got the operator, the new operator license, we asked we start the process with the Austria control, right? In this case, we need about 3 months, more or less. And then we need a lot of confidence and we need a lot of patience to work with drones in Europe and with the current regulations about that, right? It's really, really hard and really, okay, slow.
Okay, thank you. Irina, did you want to come in there?
Yeah, I wanted to comment that the national regulation is sometimes even stricter and more limited. And obviously there could be done a lot with the drones, but we are having a lot of obstacles. And we are right now doing another project with the airports, for instance. And just to give an example from airport is so the same procedure operator as from the owner side and licensed. But okay, the easiest part that you have aviation control directly at the airport, and they are assessing. But what the airport had to do, assess the risk and have a risk procedure in case of different scenarios. So the scenarios are now identified, like potential, and then they have response, and there is a safety manager. Maybe that's a way forward also for the motorways, for instance, that you have assessment of the risk. So they have this, it's called exceptional protocol for safety endangered situation. We found a way to go around because otherwise it's impossible. And the other way I wanted just to comment, we all know, for instance, for bridges, there are standards which are very conservative, and they say, at least in Croatia, visual inspection has to be performed, that the expert has to be able to touch the surface of the, let's say, bridge, which immediately, whatever you do with the drone, and you know that you will have much better record of the damages and everything, but it cannot be recognized as official bridge inspection. Even you will have a record and you are able to classify the damages and do the assessment, but based on the current regulation, it says visual inspection, yeah. So it's really ridiculous, and we have to, I would say on a much higher level, get rid of those regulatory obstacles.
All right, thank you. Do we have any questions from the audience? If not, I might keep going. And sorry, okay, we have them there at the front.
Yes, Rod Franklin from CUNA Logistics University. I have a question for all of you on the recycling process for the tarmac that you put down, the asphalt. You all, several of you mentioned that you were recycling using rubber or pecan shells or things like that. Have you looked at the life cycle length of existence versus pure asphalt? Because generally they recycled products don't last quite as long.
Okay, I think it's a bit of a loaded question there. So, Who would like to go first?
I'm not the asphalt expert, but I can try. At the moment, the research, so I absolutely agree, and that's the point that the innovation assessment has to go through the whole life cycle process, including also, of course, the energy used for recycling, and then the estimated life cycle. For those completely innovative materials, unfortunately, I don't think we have implementations which lasted for whatever, 10, 15 years. So they are based on the laboratory simulation of the environmental conditions. So I think it will take time to have a real picture how they behave in the real environment. That would be my answer.
Yeah, from my point of view, the thing is that we see from other sectors that reuse is sometimes seen something expensive or unjustified. Yeah. So the thing is that we are working in a sector with a very big inertia, and we need to, if we want to implement these kind of solutions, it's not a problem. It's not only a problem of the material. It's a problem of material, of processes, of tenders, of the complete value chain. So it's true that now we see that some green possibilities to develop new solutions, more eco-friendly solutions. But the thing is that we need, if we want to implement them and we want to demonstrate, if we want to demonstrate that it's effective solution from the life cycle cost perspective and so on, we need to change completely the way we are doing things right now. It's not only about the material, it's about the material, the process, and the way we are doing everything. It's a change of paradigm, let's say. It's something similar to the thing we are seeing right now regarding the reuse of electronic components, for example. Yeah, this is at least my view.
Well, I completely agree with the previous points. I just would like to add on that in this respect, I think there's also not a full alignment from at the European level. So I think there are some countries in which this type of recycled materials are implemented easier. From our experience in the project with AFASH, in France, this is much more of a usual practice to use recycled asphalt pavement and also chrome rubber. And I would say that the findings from their side in France, where I would say these type of materials are more widely used, is that up to a certain percentage, I don't have the exact number because I'm not an expert on the field, the results are quite good and the durability is not so much affected, but this is within some barriers.
Finally, my case is the same that Irina. I am not expert in the asphalt in these issues, and to be honest, in the InfraROB project, the life cycle of the asphalt was not the main component or the main, let's say, the main objective of the project, right? Then the main objective of the project was to develop solutions for automatize the process, for reduce the cost and reduce the workers, etc. But the life cycle component was not the main focus of the project. And despite of that, some partner has encountered this component, but in a collateral manner, right? And not in the main focus of the project.
Okay, thank you. I might follow up from that with maybe a question for David and Irina regarding, again, moving maybe to circularity. And Irina, earlier on you used the phrase that the existing strategies are not circular strategies. And David, you also mentioned just about a new paradigm being needed. So in terms of that shift, do you think that's needed to maybe make our infrastructure management processes more circular?
Yeah, I would say that European level has a very clear Green Deal and European action plan, climate action plan. But then the implementation has to go on the national level, and the governments have to make it very clear how to fulfill those objectives. And what I would say that there are no incentive measures to implement the circular solutions at the moment. So there is always a pressure of price and time, and circular solution is not necessarily the cheapest and the quickest. In the sense of evaluating the solutions, whatever, I mean, we are even maintaining the existing infrastructure. So also the new, I think, new Eurocodes are very limiting in a sense that all the existing infrastructure has to satisfy the new loading requirements. And we know, you are very well familiar with that, that the existing bridges will not fulfill the requirements of the new traffic load. And then the solution is replace. Like, we have to become, I think, much more flexible and probably there should be incentive or supporting measures for implementing circular solutions. That would be my insight.
Okay, thank you. David? Yes.
I'm from my point of view, I think that okay, circularity is an opportunity to change the way we are doing things. But at the same time, I think that there is a hidden market regarding the reuse of materials, the reuse of components. And the society nowadays think that this is something expensive and luxury because it's something, an additional problem we need to save. But the thing is that we need to all of us as society to make this market to go up and see that to make this market real, we need to make use of digital tools that we have now, right now, that's such as the digital twins, the different technologies and solutions we have to guarantee the remaining life of these components and these materials and so on and so on. I mean that there is a hidden market that could make this circularity and reusability real, but we need somehow to apply all these solutions that we are developing for this, and I think it's the only way to do it. Yeah.
Okay, thank you. Do you have any other questions from the floor? If not, I might just ask one final question, which is, again, just following up on the point about digital tools. I was struck by the different ways in which digital twins have been used by each of you in terms of the quite different, maybe, use cases. So whether it be for maintenance, resilience was also mentioned, and now procurement and promoting of circularity. Maybe I might just ask each in terms of how you see the use of digital twins evolving, maybe from your own particular applications as we move on from these projects.
So, well, in let's say, talking from the perspective of OMICRON, digital twin was one of our main areas of research, as I said, focusing on pavements, bridges, and how we plan maintenance. So from the condition state side and from how this affects how we plan maintenance. And, well, following, let's say, in short, what I said in my last slide, I think we have made a very good progress, which allows us to have more information on the infrastructure from historical and IoT and real-time data that we would say can be applied towards resilience and most specifically towards how we tackle certain extreme events that may happen. And in this case, I'm referring perhaps closely to the recent fast floods in Valencia within this year. So catastrophes like this, I think, can be supported, can be helped to solve by digital tools that can act quickly and efficiently. And I think that's something we need.
Okay, thank you. Please, Pedro.
Yeah. Under the perspective of InfraROB, we have developed a digital twin. And in my view, in my opinion, the digital twin is a part of the digitalization process of the infrastructures, right? It's a key component, in my view, for any other consequence or any other objectives that in general, the European Commission are following in relation with the reduce the waste and increase the recycled use of materials, etc., etc. But the digital twin has a lot of components or different let's say, different applications, right? In our case, the digital twin that we have developed in the project was focused in the improve the maintenance operations of roads, specifically the asphalt ladders, and increase the duration of that, reduce the cost of maintenance, etc. Right? This was our objective, and the focus was put in these characteristics of digital twin, and for that we have developed a pavement management system for integrate with the digital twin and considering the robots activities, robot actions, etc. This is the focus and the main characteristics of our tool, of our framework, right? But it's clear that they have many other, let's say, components, objectives, etc. But in our case, we put the focus in these characteristics.
Okay, thank you.
Yeah, in my case, in case of LIAISON, we are using digital twins well, for different applications, but the most relevant one or the most important one is the one focused in energy, in the optimization of the energy, of the lighting consumption and also the tunnel fans consumption in the tunnel. The thing is that here we use the digital twin to help in the decision making, suggesting or providing different scenarios and to speed up the process in the multi-scenario analysis to identify what could be the most optimized strategy to activate the different components of the tunnel. So I mean I think digital twins, it's a tool that is really powerful, but the thing is it's not necessary always and for everything, but sometimes it's necessary when you need to analyze multi-scenarios or let's say when the linear solution is not the right one, yeah?
Okay.
And in Circuit, the focus is definitely linking the existing structures or database of the waste and existing materials with the future needs and future projects, with the idea that we have let's say the owner and who can then search first into his own database and then to any other database of the existing elements. So in a sense, I mean, I know Netherlands has already created a second-hand market for the bridge elements, a second-hand market for building elements. There is international market for instance, for the airport elements. So let's imagine that the future we are trying to really reuse and have an open source database with different components and materials. So that's the idea. So it doesn't have to necessarily be digital twin if we really go in terms of real-time representation, but as a digital database.
I would like to add that I think we need to learn from other sectors. That's why in the previous lecture we see some guys from BMW, and it's important to learn from these other sectors, because I remember some years ago they talked about the car as a service, and now we are thinking for this second market that component bridge as a service, or the bridge as a service, or the infrastructure as a service. So I think this is the way.
Okay, thank you. Okay, at this stage I might hand over to my colleague Claudia for some concluding remarks.
The conclusion for this session were, as you could take a part of, my only two recommendations I would have for this session are: one, you have seen project results that are TRL 7 to 8, which are ready for the market. But this is the need is for infrastructure owners to be willing to take the project results and to take the step forward. Then already projects are doing the first step forward in standardization. The project presented their project results to a working group in different senses. So the standards, the future is here because they are taking one step further their project results to present them to technical working groups for the next standards to include them. And then when it comes to circularity, we are just in the mid of the discussion with these two projects. But what I kindly ask you as representing of the funding authority is to take maybe not all the project results that were presented, but just the ones that are very important for you when drafting the next proposal, and just bring them back in your, bring them on your work and build on their project results. Because if the projects end like OMICRON, InfraROB, and HERON end this year, they should continue building on and continuing making progress, because we are living an era where everything is running very fast. So it's important to take each individual project results or part of the project results to the next level. And this next level can be, even though you were not part of the consortia, but just to take contact with the project partners and build on in the future proposal for future projects. And when it comes to next steps in funding, as already my colleague Pedro told you about Innovation Fund and CEF projects, do look for opportunities for these project results to be taken to the next level in a CEF project or Innovation Fund. And from my side, I would like to convince you or to make you understand that we are trying to make the progress in standardization and regulations, and more specifically to innovation procurement. We are planning to have next calls on innovation procurement. Therefore, everything that is now today as an innovation to be able for the road operators or national road authorities to take these results, but they will need to have this regulation. So we are working on this. And the last thing that I kindly ask you to think about and take home and then give us as feedback, if you're a project or if you're an external wanting to be part of projects funded by the Commission, every time you encounter challenges and facing different elements like regulation, permits, flying drones or whatever, please keep a list of things that you find that are preventing your work to go further when it comes to infrastructure, road infrastructure or whatever infrastructure, road maintenance, circularity, whatever, and always interact with the project officer and give this list of recommendations for us to keep ourselves closer to you, because it's really important that the next calls reflect what you need to be able to see in them so you can apply to next calls and build on whatever is now delivered for better and uniform research and innovation at the European level. So thank you. Should you need to ask something, please contact keep in touch with my colleagues in the lunch break. And I think we are now finished the session. If you would like to add something else, thank you so much for the presentation. Thank you so much for participating in this session. I do hope that you'll take something from it, and do please interact and build on next consortia, and we meet in the same context or similar context in the future. Thank you. Have a nice day. All the best.